Hey, what's up, guys? This is Chung here. So today, let's take a look at today's daily challenge problem number 56, merge intervals. You know, this one is one of the most classic interval problems. Okay, so you're given like a array of intervals where it has like start and end, right? You need to merge all the overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in the input. Right? So we have this 1, 3, 2, 6, 8, 10, and 15, 18. So 1, 3, and 2, 6 can be merged into 1, 6, and then 6, 8, 10, and 15, 16, right? So keep in mind here, right? I mean, even the starting point and ending point are the same numbers, they still can be considered, they can still be merged. So for this kind of problem, it's always you will always need to sort it either by the start date or by the end date. And for this kind of merge interval problems, we always sort by the start time. And if this one is asking you to find if you guys have remembered the least meeting room you need, right? And then probably for that kind of problem, you need to sort by the end time. But anyway, so after sorting by the start time, then it's pretty straightforward. There are like many solutions or many like ways you can implement this, right? So one of the ways is that you start from this one and then you keep track of the last end time, right? And see we have 1 3 here. That's why the we have 1 3 in our final answers, and then when we see 2 6 here, okay, so first we check if 2 is still within the range, right? If 2 is still smaller than the current end. If it is, then we will try to extend this end time, right? So for this one, because 2 is within 1 3, that's why we will try to extend this end time to 6 because 6 is greater than 3. So now we have 1 6. We have 1 6 here. Okay. And we'll insert when the start time is greater than the current end time, right? That's when we need to insert a new one. And then we keep going until we reach the end. So that's the first solution. I'll just quickly implement that. So like I said, so first we always need to sort. We do a sort here. In Python, if you don't do anything, suppose you have two elements here, it will sort by the first one, by the first element by default, and then sort by the second one. So we don't have to specify any lambda key sorting key here. And then we have answer equal to 0, equals to the empty, right? And then for the start and the end in intervals, right? Okay, and so when do we need to append, right? So if not answer, if answer is empty, or or the the top one, or the interval, or the start is greater than the last ending time, which is the answer dot minus one dot one, right? So that's this is the last ending time or the current ending time. And then we will dot append the s dot end, right? Else we do what? Else we'll, like I said, we'll try to extend the ending time for the current. So else here is that it means the s is within the range of the previously ending. So here we'll try to extend the current ending time, which is the minus 1 1. That's the max of the answer dot minus 1 1, and then we do an end. So keep in mind here, so we cannot use the tuple here because tuple in Python is immutable, And since we'll be updating these values later on, that's why we have to use a list. Okay. So, and in the end, we simply return the answer. Yeah. So that's that. Let's try to run the code here. All right. So it's accepted. I mean, yeah, it's pretty straightforward, right? Basically, we're trying to follow the this problem is asking us to do. We set the range, and then if the next one is with the starting point is within the current range, we'll try to extend the ending time. If not, we'll just start a new interval, right? So the time complexity n log n, right? Because the sorting, and here we have n. That's why the time complexity is n log n. So actually, after this one here, there are like a bunch of other ways you can do it. I'll just write another solution here. So another solution is that, we keep track of the previously start and end, start and end time. And then whenever we reach a new one, whenever the current s is greater than the previous end, that's when we do the insert. Sorry, that's when we do the append. Otherwise, we'll just keep stretching it until we have reached a starting point which is greater than the previous ending time. So something like this. So we have 1, 3, 2, 6. So we have 1, 3, and then we try to extend this one similar like the first one. So I have 1, 3, and then we have 2, and then the first one is supposed to be 1, 6. And then whenever we have a 8, which is greater than the current end, then we do an insert. Otherwise, we'll just keep expanding it. So I'm going to have a previously a starting point equals to the intervals. So 0 dot 0, and then we have a previously ending time equals to intervals 0 dot 1, right? Then we have n equals to the length of the intervals. So for I in range 1 to n, since we have already set up we have already used the first intervals, that's why we're going to start from the second one. And then we have a s dot end in the intervals dot I, right? So if the s is greater than the current end, than the previously end, right? Then we do we answer dot append dot current s, and then previously s and the previous end. And then once we do that, we will also update the previous s and the previous end with the current s and the end, the start and end, right? Else we simply do a current end, sorry, previous end is equal to the max of previous end and the current end, right? So that's how we update. If the s is still within the range, we'll only try to extend this end, right? So, and then, but for this kind of approach that, we have, when we reach the last one, when we reach the last element, it will not be handled here. So that's why, in the end, we also need to do a append here. We'll just append the last pre intervals by doing append one more time here. And then we simply return the answer. So for this approach here, since we're not going to modify we're not going to do a in-place modifications here, we can just simply use the tuple here. Okay. So if I submit this one more time, yeah, it's also successful. Yep, I think that's it for this problem. This one is like a very one of the very basic problem. There are like a lot of variations based on this basic form of interval problems. It's good to understand the logic and the meanings, right, of this kind of sortings, and then we do a comparison with the ending point. Yep, I think I'll just stop here. All right, cool guys. Thank you for watching this video and stay tuned. See you guys soon. Bye bye.